Hi guys, today we're going to talk about solving linear systems by using substitution. So far we've learned two methods of solving linear system. The first method was graphing, and the second method was linear combination, which is also called elimination. Okay, so we're going to talk about the third method today, which is called substitution. Okay, so how can we solve systems algebraically using substitution? What do we need to do first? First of all, we need to isolate one variable. So for example, if you look at example A, y is already equal to 3x and x plus y equals 36. Now, one of the variable is already isolated. So we can definitely use substitution. So we know that y is same as 3x. Is that right? So now what we're doing is number 2, substitute the expression into the other equation. What does that mean? Y is same as 3x. Is that right? So on the second equation, what we can do is instead of y right here, we can substitute that y with 3x. So instead of this y, we're going to put 3x. Okay? And then we're going to bring down exactly as it is, rest of them. So we bring down x plus equals 36. So all you're doing is instead of this y, we substitute y with 3x. And 3x I just substituted. Why did I substitute? So that I don't have to have two variables. Now I only have one variable in terms of x. So I can solve this equation so easily. So x plus 3x is what? There's an invisible 1 in front of x, so it's going to be 1x plus 3x, which is 4x, equals 36. Okay, now then what do? You divide by 4. So x is equal to 9. Right? Once I get the x value of 9, then what do we need to do? I need to go back and then plug it in so that I can find the y value. Look, y is equal to 3x. So all you're doing is you plug it in 9 with x. 3 times 9, which is 27. So x is 9, y is 27. Okay, so we can check your answer. 3 times 9 is 27. That's good. And then x plus y equals 36. So we can just substitute 9 plus 27 equals 36. Therefore, it's a solution. It's 9, 27. So this substitution method is very handy when we have one of the variable isolated already. So let's take a look at the second question. Now, second question is already isolated. Okay? Now, which one is already isolated? If you look at the second question, 2x plus 6y equals 15, x equals 2y. So x is already isolated. Is that right? So we know that x is same as 2y. Okay? Since x is same as 2y, we can substitute x with 2y on the other equation. So look at this top equation. We have 2x. I'm going to rewrite it. I'm going to rewrite it so that you can all see it. So I'm going to just rewrite it. 2x plus 6y equals 15. Now, as you know, x is same as 2y. X is same as 2y. So for this x, instead of this x right here, can I just put 2y there? So I'm going to replace this x with 2y. Always when I substitute, I put parentheses. And then I bring down the rest of them as they are. So 2 plus 6y equals 15. 2 times 2y is 4y plus 6y equals 15. What? Now, the reason we substituted again was so that I can have only one variable. Instead of x and y, I can have just y, so I can solve 4y. 4y plus 6y is 10y equals 15. Then you divide by 10. Y equals 1.5, which is 3/2. Okay. Now, once I get the y value, what I can do is I can just substitute right here so that I can solve for x. X is equal to 2 times 3/2, which is 3. So x is 3. So, as you know, x is 3, y is 3/2. Okay? So, we only use substitution if one of the variable is already isolated. Actually, what we can do is we can isolate the variable to use the substitution, but we don't really need to use substitution when one of the variables is not isolated, So we're going to do more practice of that in class, but that's the essence of it. So all you need to do substitution is you need to have the variable, one of the variables already isolated, and then you just substitute that expression so that I only have the equation in terms of one variable. Okay? All right. Then I'll see you in class. Have a good day.